By 2025, incredible auroras will appear worldwide, causing planes to start falling from the sky. By 2027, ocean levels will rise and flood cities like New York, San Francisco, Los Angeles, and Miami. And in 2030, the ozone layer will collapse, leading to mass extinction. All these horrors are supposedly due to Earth's magnetic poles switching places. If you've also seen videos like these, leave a comment below. Meanwhile, I decided to investigate what these predictions really mean. However, when I delved into the actual scientific research on changes in the magnetic field, it became less amusing for entirely different reasons. So let's get to the bottom of this once and for all. Can Earth's magnetic field really kill us? First off, I was shocked to learn that scientists still don't know exactly how Earth's magnetic field came to be, since other planets in the solar system don't have similar fields. Our planet looks like a complete oddity. So where did it come from? According to the prevailing theory, inside our planet, there are two cores. An inner solid one made of an iron-nickel alloy, and an outer liquid one made of molten rock. The liquid core slowly cools down and releases heat waves that rise and create a convection flow. Thanks to Earth's rotation, these flows spiral and generate a magnetic field around the entire planet. Basically, it works just like a dynamo bike light. Remember this bit about the core because it's going to be super important later on. But how did this magnetic machine under our feet even get started? There's a theory that 4.5 billion years ago, a Mars-sized planet named Theia crashed into Earth. The impact sent part of our planet into orbit, becoming the Moon, and Theia's core merged with Earth. Its remnants are located beneath West Africa and the Pacific Ocean, and are the densest objects in our planet's mantle. Some scientists speculate that the energy from that collision, along with the iron-rich fragments of Theia, if not kick-started, then at least significantly boosted Earth's magnetic field. However, even the top experts in the field can't explain why the magnetic poles never match up with the geographical ones, even though because of Earth's rotation, they totally should. Since their first discovery, the magnetic poles have been shifting northwest by an average of 40 km per year. But then this process really picked up speed throughout the 20th century. The North Pole shifted by over 1,000 km. And in the last 40 years, its movement speed has increased almost sixfold, and it's happening in fits and starts. In 2019, scientists created a computer model of the magnetic pole shift and concluded that the cause might lie in warm hydromagnetic waves rising to the surface from the outer core and getting amplified within it. It's like resonance when a rotating object shakes itself. But a definitive answer remains elusive since they only use data on pole movement since the 1970s. Meanwhile, some scientists outright doubt that the Earth's core has anything to do with creating the magnetic field. Professor Gregory Riskin from the McCormick School of Engineering and Science believes Earth's magnetic field is actually created by the oceans. Sounds crazy, right? But Riskin points out that salty water conducts electricity well and is constantly in motion. So changes in the North Atlantic currents could be linked to the jerky movements of the magnetic poles. Mind blown yet? The fact remains, the scientific community doesn't have clear answers about the nature and behavior of the magnetic field, and that's pretty scary. At least scientists have figured out that the magnetic field has changed and caused cataclysms in the past. Recently, archaeologists analyzing the composition of Mesopotamian clay tablets noticed that the iron particles in them were magnetized. This means that 3,000 years ago, Earth's magnetic field was almost 3 times stronger than it is now. Similar anomalies have been found in artifacts from China, Bulgaria, and the Azores, and there's no explanation for this. However, ancient people couldn't feel this strengthened magnetic field because they didn't have electronic devices. But everything changed in late August 1859, when a young English astronomer, Richard Carrington, witnessed an incredibly powerful solar flare. It interacted with Earth's magnetic field, which usually protects us from such radiation, and triggered an unprecedented geomagnetic storm. Night turned into day in America due to green and crimson flares in the sky. These kinds of auroras are usually seen only in Arctic latitudes, but they were observed in Cuba, Jamaica, and Hawaii at that time. Meanwhile, the telegraph, essentially the internet of that era, just shut down. Machines sparked, burned telegraph operators, and scorched paper. This was the first documented solar superstorm, causing the most intense geomagnetic storm in history. The future might bring us quite a few surprises since the sun has been quite active over the last 3 years. According to scientists, the peak of solar activity is expected in 2025. If a powerful flare hits Earth, the magnetic field will generate electrical currents near the planet's surface. If they are too strong, even turned-off electronic devices could malfunction. That sounds terrifying, but what about those mass extinctions from apocalyptic forecasts? It's a complicated issue. Scientists from the University of Liverpool studied the cyclic changes in the magnetic field over millions of years through ancient lava flows in Strathmore and Kinghorn in eastern Scotland. It turned out that about 120 million years ago, the intensity of the geomagnetic field was less than a quarter of what it is today. Scientists have dubbed this period the mid-Paleozoic dipole low, and it's just part of a cycle that lasts 200 million years. Throughout this cycle, the magnetic field fluctuates from very weak to anomalously strong, like back then in Mesopotamia. Yet the consequences of such fluctuations for life on Earth are practically unstudied. Some scientists believe that the mass extinction at the boundary of the Devonian and Carboniferous periods, 359 million years ago, occurred due to an increased level of the sun's ultraviolet radiation coinciding with the weakest readings of the magnetic field at that time. That is, it couldn't protect the ozone layer from solar wind and cosmic radiation, which caused harm to living beings. However, the apocalyptic forecasts talk not about weakening magnetic fields, but about them swapping places. Here, I must say, the so-called magnetic field reversal is, to put it mildly, overrated. You've probably heard about the Adam and Eve story by engineer and ethnologist Chan Thomas. In it, he promotes the idea of simultaneous shifts in the magnetic poles and Earth's crust. According to Chan Thomas, this triggered massive earthquakes and volcanic eruptions 7,000 years ago. Giant tsunamis slammed the coastlines, and all land was completely submerged underwater for several days. That's the ultimate Great Flood. This apocalyptic scenario even made its way into the disaster movie 2012. But from a scientific standpoint, it's a total no-go. A pole shift doesn't mean Earth's crust gets shuffled around. It's stuck too tight to the mantle. Plus, scientists have concluded that in the last 83 million years, the poles have swapped places at least 183 times without any catastrophic events tagging along. So on average, a pole flip happens every 450,000 years. The last time it could have happened was roughly 7,000 to 80,000 years ago. Apparently, modern humans have never experienced a pole reversal, and what's more, it's seriously overdue and messing with predictions. But can we at least make an educated guess? It seems that for the magnetic poles to flip, the field first has to weaken a lot, almost disappear. In the last 3,000 years, it's weakened by 30%. But for the magnetic poles to swap places, this drop has to hit at least 90%. According to current forecasts, this isn't happening in 2025, but more like 3025. Phew, we're not living to see planes falling out of the sky. But even then, it's most likely not a threat to all life on Earth, just to electronics. I wondered, what if the weakening of the magnetic field doesn't stop at 90%? So here's the real deal on a magnetic apocalypse you won't hear about in viral videos. Remember, I mentioned that the information about Earth's inner structure would be crucial. In January 2023, researchers from Peking University, Xiaodong Song and Yi Yang, noticed something super odd about Earth's inner solid core. In 2009, it practically stopped, then started moving in the opposite direction to Earth's rotation. Scientists think this process works like a swing, and the next time the core will change its movement direction will be shortly after 2040. But since we don't fully understand how the magnetic field is generated, what if these inner processes don't just weaken but outright switch off the magnetic field? There's a zone in the South Atlantic where the magnetic field is strangely weak, and this hole is gradually growing. Nobody knows exactly why, but because of this, space missions avoid this area since their equipment can fail due to charged particles that the magnetic field no longer deflects. If, for some reason, this anomaly spreads across the entire planet, essentially meaning the field shuts down completely, we'll have a massive problem. Right now, Earth's magnetic field traps charged particles from solar winds, creating what's known as the Van Allen belts. These belts have been a significant issue for any spacecraft trying to reach deep orbit for decades, because the radiation levels in these zones are 10 times higher than at nuclear power plants. If the magnetic field suddenly vanished, the Van Allen belts would disappear too. This is bad news for NASA, and here's why. Without natural protection, satellites and astronauts aboard the International Space Station would literally fry. Forget about the Artemis mission to the moon, and any other space travel for the next few centuries. Moving around on Earth would also become harder since GPS satellites would fail. Even old-fashioned compasses wouldn't save us because they'd stop pointing in the right direction. Instead of pointing north, compasses would react to the nearest magnetic source, like iron ore deposits. And this would affect more than just us. Birds that navigate using magnetic lines would get lost during migrations, and sea turtles and lobsters would wander the seas aimlessly. Their possible extinction is just the beginning. Insects would lose their orientation and fail to pollinate plants, disrupting food chains and causing famine. Forget about coordinating the redistribution of limited resources. Complete technological collapse would follow the next solar flare, like the Carrington event of 1859. Without a magnetic field, charged plasma would directly hit our electrical devices, and everything, communications and electricity, would be gone. If that weren't enough, the sun would destroy the ozone layer, leaving us at the mercy of its ultraviolet rays. Imagine such a scorching day at the beach that no sunscreen can save you, and skin cancer starts immediately. Furthermore, over the next few centuries, solar wind would gradually strip away Earth's atmosphere without the magnetic field's resistance. This already happened to Mars when its magnetic field disappeared. Earth would become more like the red planet, with deserts, cold temperatures, and very little oxygen. Stepping outside would feel like being on top of Mount Everest, freezing and suffocating. This is a real apocalyptic scenario that almost no one talks about. Unlike the fictional disasters from pole reversals, yes, the magnetic field could kill us, but only if it completely disappears. However, scientists can't say how likely this scenario is because they still don't fully understand how the field forms. But if it does disappear, is there a way to restart it? Scientists are already developing such a project for Mars. First, they plan to direct an asteroid to create a moon-like satellite. Then they'll heat the core with a series of underground nuclear explosions. Sounds epic, right? But something tells me we wouldn't want to try this on Earth. So let's appreciate our magnetic field for what it is and how reliably it protects us from doom, except when it messes with our electronics during solar flares.